Hey guys, Smail here with another video about AI and machine learning for money and business. So this video is the second part about teaching AI to sell cars. So basically it will be about building a RAG system for a car dealership. Every code that I will show you will be available via the link in the description. Let's get started. In this part, I will guys tell you about the web scraping phase of the project and how did I come up with building the dataset that will serve, for our RAG system. And then I will tell you more about the evaluation datasets that I came up with. Actually, this was super tedious and it took much more work than I expected. And finally, I will touch upon the next video and what I will be talking about next, basically. First, for the web scraping, my goal was to use tools that are like super fast to use or that are super cheap or very cost efficient, And basically, I looked at multiple AI scraping tools online. I went ahead on YouTube and I just looked for AI web scraping tool and I found this first video. This tool, Thunderbit, seemed nice at first, but then they said that it is only free for the 6 first pages, and then it becomes like a subscription of either $15 per month or $38 per month. So this tool was quickly discarded and couldn't be used for the project. Other than that, there is also this YouTuber that talks about using like DeepSeek AI to scrape any websites for free. And when I went through the methodology that he uses, basically what he does is that he uses like a tool called Crawl AI, and you give it just like some URLs and then it outputs the HTML, and then you need to use DeepSeek to interpret the HTML. It is not very good as a methodology and it relies on DeepSeek, and you don't know all the assumptions behind this Crawl for AI. So basically I ended up not using any AI tool, and what I did is that I used Selenium, which is a Python library. I'm super familiar with it, and it allows you basically to give you the tools to automate Chrome. So it can open Chrome, it can open any web page, right? And it can also perform actions within like a web page, either clicking on something or scrolling and so on. So it is super handy for automation and web browser automation in general. And after a lot of work, web scraping the pages for this car dealership, I realized that it was the best choice in hindsight, to choose Selenium. So for this web scraping, I had to do multiple steps. The first one was to read this sitemap.xml file to get all of the listings. And let me clarify, what do I mean? First, we have the website that I told you about, which is premiumcarsfl.com. If you go to the website /sitemap.xml, it will go to this web page, and you can see here that we have multiple sitemaps URLs, that we can use. We have posts, page, and so on. And what we are interested into is this listing, because it contains all the listings that we need. And if you open it, you end up with this file here with all the possible listings that are available on the website, basically. And we have the first URL, which is the root page, and we don't need it. We only need all the other ones. Basically, if we do Control F and the listing / we can see that here at the moment we have 158 listings, but when I downloaded everything at that moment, there were only 151 cars, basically. So yeah, that's basically the starting point of the web scraping. This is an example of one listing. So it's a 2023 Toyota Corolla. It's a sedan with the price here, with the specs, And my methodology was to come up with some Python code that uses Selenium, right? To fetch all of this data, whether they are the specs, the description, the title, the price here, or the location, and then so that whenever everything here works, I can apply it to any listing, basically. All we need is an input, which is the URL, right, of the web page of the listing, and then apply the exact same code to every single listing. Now, the problem with this methodology is that for this specs part, this part here, I realized that it is, the data provided is not consistent. They don't all provide this type of data. Obviously, there is some data that is common across all listings. Obviously, the body style, the make, the model, the color, and so on. But some data types, are not provided. For example, here we don't have like the highway miles per gallon or the city miles per gallon. And this data is available for some other listings, and I realized this. So basically, we need to do some kind of dynamic web scraping. What I mean is that instead of, preparing, like telling Selenium to go directly to this localization and take the text, and then go to this localization and then take the text and so on, and do that for everything. What we need to do instead is to just look for this area, right? And then to loop over all the items, whatever the items are, because some, as I said, some will be provided and some will not. So basically, this is the methodology that I used. And what I ended up doing is that I created both a CSV file and a JSON dataset. The reason I did that is that I created a CSV file because after that, I can easily read the CSV file using Python, but more importantly, I can filter it, and do aggregation operations. For example, what's the average pricing of Mercedes or Toyota, or what are SUVs under 30,000 miles, we can do that very easily using CSV, basically. And also, the advantage of using a CSV is that we have all possible columns, and sometimes, obviously, when there is the data, there will be like, the row will be filled, and whenever we don't have the data, some columns will stay empty. However, for the JSON dataset, for every single listing, we have only the data that is provided. And I think I will end up using this dataset for, our embeddings for basically the next video. And guys, some tips. So the first one is about making the script wait before scraping a listing, because sometimes, Selenium will want to go fetch some data before it has been loaded, So there is like a very handy code that you can use that waits until all HTML elements have been loaded, in Selenium before performing the fetching of the data. Also, there is an option called headless, which means we don't display the browser, the window. We don't display it because it allows us to do the scraping in a much faster way. And basically, the second tip is about enabling this option if we want to speed up the scraping, because if we loop over all the 150 data samples, we don't want the browser to open a new window every single time. It will be super slow, right? We want to do everything in the background, and we want it to be fast. We also need to disable headless option, to check if some actions are done correctly. Normally, when Selenium opens like a web page, a listing, it will be shown that way, And as you can see here, the description is not shown. We need to perform an action. We need to click on this show more so that it will reveal the rest of the description so that Selenium can scrape it. And basically, in order to double check that this action is indeed done by Selenium, we need to allow this, we need to disable, this headless option so that it will actually open the browser and let us see and double check that the action has been taken. So this is just a tip, guys, to make sure that everything is performed as planned. Now I will go through a quick code review about the Python file that I wrote to do the web scraping. First, I wrote this function, read the log tags, which will read this XML file. And let me show you guys the XML, how it looks like. So if you open this file in a text editor, you will see something like that. Basically, you have URL tags, and inside every single URL tag, you have a lock. Basically, we need to extract the lock, which is basically the location, except the first one, right? So yeah, basically that's Python code that I just showed you. Just reads and parses this file and extracts every single URL contained here. This function here, getDriver, will just be used to start the Google Chrome bot, basically. I also coded the account token function because I was curious to know on average how many tokens like one listing would have. And basically, I just coded this, out of curiosity, and I think the result was about 700 to 800 if we take into account the description, which is pretty long, as well as all the specs of a car. For me, one of the most important code snippets is this part here, because first we are waiting, until some elements appear, and those elements actually is the list of specs that I told you about. And here we are looping through every single element, and then, basically adding that into a dictionary. And if you have noticed, I'm using XPath, which is basically a way to locate HTML elements within a web page. So basically, it's like a special type of language that we can use that libraries like Selenium understand to know exactly where to go fetch the information. And the most important code that you need, guys, is this function here, which is download data, CSV, and JSON. Because if you call it, it will download every single items contained in the XML file. And as you guys can see here, at first I was using every single location, of every single spec to go and fetch it before, realizing that the data was not consistent. So I just kept this part here commented. If you guys are curious to know if you would be able to get the XPath on your own and compare it, with my own, guys, feel free to reuse it. But at the moment, it is just commented because it is not used. And this is, guys, a screenshot that shows how this will look like, once it will start downloading. So basically, for every single listing, you will have processing, then the name of the URL, basically. And then once it is done, it will just print done and move to the next listing until everything is finished. Now the next part is about building the datasets, and if getting the CSV output or the JSON file is pretty straightforward, as I have shown you, I also decided to build graphs out of the JSON file. The reason is that, as I told you in the first part, of this series, I'm treating this project as a research and development project, and we need to compare multiple alternatives, multiple approaches, right? And the first approach will be based on embeddings, chunks, and so on. And the second part, will be based on graphs, and graph rags. So yeah, I also decided to build graphs using Neo4j and also Python to generate the Cypher queries. So Neo4j uses a specific language called Cypher to build graphs and query them. And actually it was not that easy to do because Cypher needs a specific syntax, and you shouldn't, include many types of characters when building any query. Let me show you what I mean. This screenshot here shows the Cypher queries that were generated via my Python script. So we have create, vehicle type, and so on. And as you can see, we have a syntax error, invalid input. So one of those characters were inside my query, right? And we need to basically clean the queries and sanitize them to make sure they don't include any of those characters. The second reason why this was not as easy as expected is sometimes, you don't have any bug, everything is running smoothly, but you have what we call logical errors, and those need manual verification. And I will show you one example of that. So here you can see the graph that was created, after the generation of the Cypher queries. But you can see here that we have a car that is of make Kia, right? and that has this listing, which is here. This number here is like the stock number of premium cars, like this car dealership, basically their inventory ID. But here the bug is that here we say is year 95,175, which is impossible, right? It should have been easier 2020, right? But actually, here is the number of miles of this listing of this car. So basically, what I mean is that even though you run the Cypher queries and everything works smoothly, you still need to manually verify that the data makes sense. Also, guys, another thing that I had to pay attention to is, for this description of a car, as you can see, it contains a lot of emojis here. And here we can see this show less, which ended up being scraped too. And also we have multiple useless things like those websites, kbb.com, or here we can see +2, +1. Everything here that you can see creates noise and needs to be cleaned before being used in the dataset. Also, guys, a useful tip for building this graph is that, once you have a graph that is ready, you want to visualize it because you want to know if it makes sense, And basically, when you type the query to return all the nodes, sometimes it might be confusing or even misleading, and you might think, hey, this doesn't make sense. Maybe there is an error somewhere, right? So the best way to double check your data is actually to craft a special query, right? To just return a subgraph. So for me, for this example, what I did every single time I built like a different graph, I will just output all Toyota cars, just display everything related to Toyota, and let me double check whether the pricing, the miles, everything makes sense and is contained within the original JSON dataset. And what I did is that I went ahead and built 3 types of graphs. So the way they change is that the schema, the structure of the graph changes. So the first one is about the vehicle, as the root node. Then they are linked to brands, so BMW, Toyota, Jeep, and so on. And then we have a listing, like a specific listing, and then we have all the specs of the listing. So the mileage, the body style, and so on and so forth. Let me show you how it looks like. By the way, guys, the queries that I will be using, I prepared them in a file called useful Cypher queries.json, and those are the queries that I will be using to display, the nodes that I prepared. So, this query here is about showing all the nodes and all the graph basically that we built. This one is about deleting everything, so it is useful, when we want to go from one graph to another. This one is about visualizing the first type of graph, the second one for the second type, and this one for the third type of graph. So let me first show you what's different, when we decide to display everything versus when we want to display only Toyota cars. Here, this is what happens when we enter this query here. So let me resize this. And don't worry, guys, I will show you how to create this dataset because I also prepared the queries for you. But know that here at first it might seem, misleading because we have the feeling that every single listing, is like isolated. It is not linked to any like brand and so on. And basically the reason for this is that here, when we perform this query, we can see that not all return nodes are being displayed due to initial node display setting, This is basically just like a constraint to prevent your computer from processing too much data, because in some graphs we might have billions, of nodes and edges. And just as a precaution, Neo4j is limiting us in the number of nodes that can be displayed. So obviously, internally, Neo4j will run some query, right? And it will just display the first 500 nodes that appear. And, it might not make sense when displayed. That's why right now we'll be visualizing all Toyota cars. So you take this query, you copy it, you paste it here, and then you press play. So as you can see, it is creating a nice subgraph. Let's maximize this and then zoom in. As you can see, it is creating a nice subgraph where here we have the root node, which is a car, and we can see that it is of make Toyota, and then every single light blue circle here is corresponding to a listing, and we can see that it is linked like from the Toyota via a has listing edge, you know. And we can see that for this car, it is basically like a 2023 Toyota Camry. It is gray. It has a price of $22,500 US. It is a sedan, and so on and so forth. So yeah, basically you can have every single information about like a listing, and it is pretty nicely built using a graph. Now let me guys show you the code behind the creation of this first type of graph. It is linked to this function here contained in this file, listings to graph.py. So basically this function generates cipher query database 1. That's what it is creating this graph. And you can see here all the queries that we create, like create with the node, or here create the node with the relationship is make, and so on and so forth. So basically we need to loop through all the unique listings, also all the unique makes, right? And yeah, basically guys, feel free if you want me like to prepare for you a cipher tutorial, please comment it below, and yeah, I would be super happy to do that. But basically the result is that after iterating over all the listings and creating everything into like a string called a cipher query, we output everything into a JSON file called cipher queries premium cars Florida database 1. That's JSON, and let's open this file and see how it looks like. This is the file with all the cipher queries, right? So as you can see, it has around 6,330 lines, right? So it is a lot. So basically to create the graph, you just select all with Ctrl A or Command A if you are on Mac, and then you copy it with Ctrl C. And then you go to Neo4j. Here, since I already have a graph, I will have to delete everything before creating this graph again. So what I will be doing is that I will go back to this file called useful cipher queries. I will copy this query to delete everything. I will paste it and run it. As you can see, it has deleted that number of nodes. If you want to make sure that everything has been deleted, you can run it again. And if it says no changes, no records, just know that nothing is in your database, basically. And now we go back to the queries generated. We copy them, paste them here, and then run this cell. To run it, either you click on this play button, or what I do also is Control Enter. It will take a few seconds, I think from 4 to 5 seconds to run, but if everything has worked as it is supposed to, it will say here, added 3,157 labels, and so on and so forth, about the nodes, the properties, the relationships, and so on. And yeah, after you do this, you will be able, to either visualize this subgraph here for the Toyota, or visualize everything with match n, return n, this query that I showed you previously. The second type of graph that I decided to create is following this schema here. First, we go from the vehicle root node, then we go over all years, all possible years. Then for each year, we go through a make, and then the model, then the listing, and then the specs of a specific car. Let me show you how it looks like. Again, I will reproduce everything that I showed you to be able to create the second graph. So I will delete everything using this query, go to the second file that was generated, copy it, paste it here. As a precaution, I will just close the window related to the first graph. Then I will run it. Then you should go to the second visualization cipher query, right? You paste it here and run it. And as you can see, it shows a different type of graph. Let's zoom in and see how it looks like. By the way, here sometimes, guys, when you want to display something, the label of a node will not be shown, you know. And to show, you know, the labels, it's very easy. You just click on the node, right? And then you click on this button to reveal some options. You click again, and then here you just press the year, right? For the, I mean, this type of node is the year. So now you can see that once it is toggled, it is displayed. So as you can see, we have the root node, which is a vehicle of type car, right? Is year 2023, and then we have multiple makes. I mean, for this one, I mean, for Toyotas, we have only Toyota, obviously. And then we have multiple models. So either the Camry here or the Corolla. And for other years, we have as well, you know, Corolla or Camry. Let me see if we have some other type of... Yeah, and let me see, for 2020, we have a RAV4 as well. Here, guys, I tried to make everything readable so that you can read along. And as you can see here, it is very easy, you know, to know all the specs of this car. So basically, here, as I told you, you know, all those light blue nodes, they correspond to a listing, right? And every single listing has a list of specs, basically. So we can see that as a body style, it is a SUV. The name is a 2020 Toyota RAV4 and so on. It is located in Miami. It has more than 100,000 miles, right? For the price, it is a bit less than $21,000. It has cloth, you know, as interior. You have everything about the spec. Now, the third graph schema is, you know, a vehicle. Then we have a body style, so SUV, sedan, and so on. And then we have a price range. Basically, I created this new feature of price ranges, you know, with the 10,000 increments. So basically from 0 to 10,000, and then from 10,000 to 20, and then 20 to 30, up to the maximum, you know. I think it was up to 40,000 USD. And then we have the listing and then the specs. So let's visualize this and see how it changes. Actually, there is a unique thing about this graph representation. So we go from the car to multiple body styles. So here we can have pickup, sedan, SUV, and so on. And then we go to the price range. But the thing is that here, you know, multiple body styles can point to the same price range, which makes sense because for 10K to 20K, we can have both SUVs and sedans, right? And this is called like a diamond shape in a graph. And basically, it will be interesting to see how this graph representation will affect the accuracy, you know, of our RAG system. And this is actually a research question because we don't know. We'll test and see whether it leads to more accurate results, no change, or worse results, right? So if we follow this arrow from 10 to 20K, this, I mean, contains this listing, right? Of, I think this is, oh yeah, this is a Toyota. It makes sense because we are visualizing all Toyotas. It is located in Miami. It has a price of 17,900 USD. So yeah, everything works well, and you will be able to download this code for free, guys. And concerning the code that creates this query, this is it. Right, this is generate cipher query database 3, and basically I go through almost the same logic as the two other ones. The only different thing about this one is that we had to use a function called discover price ranges, because first, you know, we have to loop over all the listings to be able, you know, to prepare the price ranges in advance so that we'll create them as nodes and then insert them into our graph. Now, after doing all of this work, you know, I was wondering, maybe there are some issues, you know, within this dataset. So I just run like a quick check about something that shouldn't exist, which is duplicates in the VIN number. So basically, a VIN number for cars is the unique ID of every single car in the US, in the United States, right? So there shouldn't be any duplicates, right? Or another check is about seeing whether we have duplicates in stock number, because the stock number, as I told you, is like the unique identifier of a car within this company, within this car dealership. So again, we shouldn't have any duplicates. And I found like a very like super minor issue, and which were like 2 duplicates for the VIN, 2 duplicates for the stock number. I decided to not do anything about that because after I built the evaluation dataset, I realized that they are not contained in the evaluation dataset, which is important. So that's why I didn't do anything about them. Now, going to the next phase, the evaluation dataset. Basically, I prepared 60 pairs of question and answers, and don't worry guys, I will show you how they look like via a Google Sheets file. And it was the most tedious part, it required a lot of manual work. I had to come up with good questions, high quality questions, and for every single question I had to produce code, to filter the CSV to go find the ground truth, related to that question, so that I can write in like the corresponding answer basically. And another thing is that each question needs the corresponding context source, basically the number of listings that are needed to answer the question. And why do we need this? It's because we can check whether the RAG system is able, to fetch the data in the right way, right? And by preparing the right context source, we'll be able to double check whether this is the case or not. And guys, some tips to create a good evaluation data set. First, you need to come up with realistic questions. Imagine like a real lead that will ask questions to the AI. You need to come up with something very real, right? The second thing is that you need to prepare different degrees of difficulty. Some easy questions, some hard questions, some medium level questions, and so on. We also need ambiguous questions, because in real life, like a lead will ask ambiguous stuff that need interpretation. For example, what are some of your best SUVs under 20k mileage? What does he mean by best? Or hey, do you provide financing for this Toyota Corolla? What does he mean exactly by financing? This is ambiguous. We also need questions that involve aggregation and filtering, because let's say a lead asks, okay, what is cheaper, your Mercedes cars or your BMW cars? And this question, to answer it involves to first filter out all the BMW and Mercedes cars from the data set. So this is the first step. And the second thing is about aggregation. So computing the average price, which is like an aggregation operation over each brand, and all those steps are required to answer the question in a correct and accurate way. We also need edge cases, questions that involve no data. For example, how much is your Rolls-Royce Phantom listed? While there is no Rolls-Royce in the listings. So how will the AI behave, if there is no listing, We need to handle those type of edge cases. Another tip, for preparing the evaluation dataset is that for me, it could have been much faster if, after generating all the questions, I would prepare some Python code where I would be calling like OpenAI API to generate a code for every single question. I will just loop 60 times, do 60 calls, and then generate some Python code and then run it instead of coming up myself with the code. Now let's go through the Google Sheet. As you can see, this is the file that contains all the 60 questions, right? So we have the columns question, answer, the notes, when I wrote something that I found useful, and the column context source. So let's go over some of the questions so that you just get the feel, about this evaluation dataset. So here I wrote ambiguous. What color is the Honda Accord EX you listed? And here the answer is that we currently have 2 Honda Accord EX listed. Here the question assumes that there is 1 Honda Accord listed, while in reality there are 2. So it involves some kind of ambiguity, right? So we need those type of questions. I like this question. What's the most recent SUV that you have under $10,000? Because as a note, I wrote trap. There is one SUV and one minivan where the body style mentions SUV, right? So basically here the answer will be our most recent SUV under 10K is a 2019 Mitsubishi Outlander, and so on and so forth. But basically it shouldn't confuse. It should take into consideration the title of the car as well, not only the body style, of the listing. I also like this question. Show me the most expensive vehicle in your inventory. And this assumes that there is only one that is most expensive, right? But in reality, we have two vehicles that are the most expensive because their cost is the maximum, and both have the same cost, which is $32,900. So yeah, it's a good question. Another question that is ambiguous is this one. Do you have any trucks around $25,000 with low mileage? What is low mileage? And basically here I interpret it as mileage under 30,000 miles, right? Another interesting question, on average, how much does your BMWs cost compared to your Mercedes? And here this assumes that we have multiple BMWs and multiple Mercedes listed. And actually the answer is we currently have only one BMW listed, priced at X, while our Mercedes vehicles average around 21,800 USD. So guys, feel free to read the rest of the questions. I will just go through a last one which I found interesting because it involves like a real anomaly. It is this one. I saw a listing of yours in the title. It says 2019 Chevrolet Silverado, but in the specs it says it's 2020. So is it 2019 or 2020, right? And actually it is true, it is a true anomaly because here in the title it says 2019, right? But in the specs here we can read 2020. So it doesn't make sense. It is a true anomaly that should be addressed. Now the code that I wrote, to prepare this evaluation dataset is under the file named prepare evaluation dataset.py. And it is super messy, guys. Please don't judge me on that. But basically, you will be able to play with it, to test. Here, for example, this function display answer from specs, it chooses filtering. So here for this example, I'm filtering using like the model column, and basically here we want all listings that are either a Sentra or an Elantra, because here we have the OR sign. Or this function again fetch data from specs. Basically I'm iterating over all the listings contained in the JSON file, and I have multiple filters. Feel free to uncomment and check the answers, but the active one at the moment is find all cars that have cloth as interior fabric, and the AWD for the drive type, and for every single of this car, print the name, the VIN number, the price, the URL, and so on. Even at the end, I got tired by every single time creating a new function and then running it. I just, created a vanilla function called sandbox, and I stuffed like a lot of logic here that I kept commenting out and so on. So feel free to use it if you want. Now for the next video, I will be building multiple RAG techniques that use embeddings and vector stores. I will be also using multiple graph RAG techniques. I will be comparing them, evaluating them. I'll also tuning their parameters in order to enhance them, So yeah, I think this will be super interesting, and I hope guys to see you in the next video. Don't forget that everything that I've shown you will be available for free via the link in the description. Cheers guys.